Hello, ladies and gentlemen. This is Mr. Miller here with your Algebra 5.7 notes, System of Linear Inequalities. So kind of picking up from what we learned in the last section here with graphing inequalities out and making sure that you're shading on the right side here. We'll start with this warm-up. Super important that we're able to do this correct here. I'd actually go ahead and pause the video and do it on your own, see if you remember, and then watch as we go through it here again. So pause and then restart it here in a second. So again, think of this as a linear equation, ladies and gentlemen. So we're going to do our slope-intercept form. So y equals x, 2/3 x minus 1. So we're at minus 1. That's where our y-intercept starts. And then our slope is 2/3. So we count 2, 1, 2, 1, 2, 3. And then the opposite direction, we go minus and minus. So 1, 2, 1, 2, 3. This is not a equal to, so it will be a dashed line. Again, the equal to is the solid line. So again, that's the one difference here, obviously, between these two equations, is that our dashed line. And then this says y is less than. So again, I know the shading is going to be on the bottom. Until you get the hang of that, always test it. So I'm going to test again. You can test a point that works or a point that does not work. It is completely up to you. You heard me in the last video. I like to kind of test 0, 0 because that's the easiest mathematical. It cancels out a lot of things, and you can quickly get to does it work or does it not work. So if I've shaded correctly, my 0, 0 answer should not work in this equation. So I plug it back in there. 0 is my y. It's less than 2/3 times 0 minus 1. And again, I'm looking for a false information here because again, I'm testing 0, 0. And again, 0 is less than minus 1. That is false. And it should be false because again, it's not on the shaded side. So I have shaded correctly there. That is the main concept of what we're going to do here with our system of linear inequalities. We're going to be given 2. So we'll get into our notes here. We're actually given 2. We have to graph both of those out. So again, helps if you know how to make sure you're graphing, making sure you're testing, and just make sure that our solutions are working. And in this, your solution has to work for both of them. So let's get through the process here. I'm not going to write down the slope-intercept form every time, ladies and gentlemen. That hopefully is coming natural to you now. So again, this should be a y equals 3x. There's plus nothing. We'll go ahead and do that one in blue. Why not? So start at 0. And then your slope is 3/1. So 1, 2, 3 over 1. 1, 2, 3 over 1. And we go the opposite direction. 1, 2, 3 over 1. 1, 2, 3 over 1. Again, no equal sign, so this is going to be a dashed line. So we'll put our dashes in. There. And again, this is going to be y is less than, so we're going to be underneath here. So again, if you're having a hard time with that, and this is where it's really important, we want to make sure that it is underneath. Now I'm just going to kind of do this lightly here. So I'm just going to kind of do it lightly. And you'll see why I'm doing it lightly in a second. All right. But let's test it, make sure that it does work. So let's pick a point. So we have 2, 0, which is one of our solutions. Let's see if that works, just to make sure. So 0 is less than 3 times 2, and yes, that does work. So again, I just tested that point right there. That works for my blue one. Switching pens. So I'm going to use this one as purple. So we start at plus 1. So there it is. And then my slope is down 2 and then to the right 1. So 1, 2 to the right 1. 1, 2 to the right 1. 1, 2 to the right 1. And we go the opposite direction, so we'd go up 2 and left 1. Up 2 and left 1. Now again, this is an equal sign, so this will be a solid line here. And again here, this is saying that y is greater than, as long as we have them set up in this situation, it tells you that the y's have to go above the x's, so y's have to be bigger, so I know I'm going to be going on top. And again, I'm just going to do this lightly. So my answers are on top. Now, again, we want to test a solution to make sure that we shaded the purple on the right spot. So again, I believe that we're above. We can actually test our point that we did before, which was 2, 0. So we can test that again in this one. So again, 0 greater than or equal to minus 2 times 2 plus 1, and 0 is greater than or equal to minus 4 plus 1 is a minus 3, which again, I have shaded my purple on the right side. Now, here, you'll notice that we overlap our shading. We have to satisfy both of these. So when we overlap, and I'm going to use a pencil on this one, the overlap are all of our possible solutions. So again, these are not possible solutions because it's only purple in this area. This is not a possible solution because it's only blue in this area. We have to have that overlap. So my overlap here happens right here. I'm just kind of highlighting it with my pencil here. Any of those points in that area going that way, those are all of my solutions. So again, down here at the bottom, it says state 2 different solutions. Well, we know that that 2, 0 is one of them. That works because we tested it in both of these, and it just happened to be in the overlapping part, which is right there. So we just need to test another one. So again, maybe you try the next one over. So here we have 3, 0. So testing that, we test it in both of them. So I'm going to test 3, 0 down here. So plugging it in, 0 is greater than 3 times 3. And yes, that's true because 0 is, greater than, 0 is less than 9. So that's true. And then the other one, 0 has to be greater than, there we go, or equal to, that times 3 plus 1. And 0 is greater than or equal to minus 6 plus 1, which is minus 5, and that is true as well. So there are 2 different solutions that fall in my gray shaded area. And that is the system of linear inequalities there. We're looking for to satisfy both of them, not just one of them. So again, I got kind of lucky here, picking the original point that was in both spots there. Flip over to the back side. So, question is 3 minus 4 a solution of this system? So again, we don't know if it is or is not until 2 ways. You actually have 2 ways that you can do this. We can graph it out, which that's what we're going to do. We're going to practice looking at our graphs here, because I'll be asking you for that on the assessment to graph this out. So we'll be looking at where all the shadings are. And another way is to actually check it with your algebra skills. So that's another way that we can check it as well. But let's look at the graph portion here. Alright, so we got 3 different things going on here. The first 2, no problem, we can graph those with no problem. So with a y that has to be greater than or equal to our 0 there. So anytime you have a y equals a number, remember that's a horizontal line. So that's actually the x-axis, and it will be solid. So kind of like making it across here just to make it stand out a little bit. And I'll put it over here too also. And again, it is a solid line because y has to be greater than or equal to 0. So, a little mental note. I tend to do this just so that my graph doesn't get all filled up. I know I'm going to be going above that line. So sometimes I do that because, again, y has to be greater than 0. So 1, 2, 3, 4, those numbers above are greater than that. I'll go ahead and do the x also. Remember, when you have an x equals a number or an equality, that is going to be a vertical line. So we find -3, 1, 2, 3, and again, it's going to be a dashed line. So we dash our lines here vertically. And we'll label that also. X has to be greater than -3. So if x has to be greater than -3, I'm going to be going towards the right because those are numbers that are bigger than -3. And then we got a little work here to do on this one. I always like putting it in slope-intercept form. So I'm going -2x. So 3y is less than or equal to -2x plus 6. Divide by 3, divide by 3, and y is going to be less than or equal to a -2/3 plus 2. So again, plus 2, 1, 2, and then a -2 over 3. Or again, if you want to do the opposite direction, you can do your +2 and then a -3, either way. So I'm going to do -2 first, 1, 2, and then a +3, 1, 1, 2, 3, so there's 1, -2 and +3, 1, 2, 3, and then the other direction, so up 2 and to the left 3, 1, 2, 3, up 2, 1, 2, 3. And again, we have an equal sign, so we have our line there. Y is less than, so again, for this one, we're going to be shading underneath. And then I'll bring in my blue marker here to get all of our shading. So we want it to be to the right of this line, above this line. So if I'm just looking at these two intersections right here, I'm to the right and above. And then I need to be below this line. So the only part that is shaded in this is that section right in there, that little triangle. And they're asking us, is 3 minus 4 a solution? Well, where's 3 minus 4? 1, 1, 2, 3, and then 1, 2, 3, 4. There's my 3 minus 4. Is that inside my blue shaded area? And the answer is no. So is this a solution? Absolutely not. And again, where does it fail? Mathematically, it passes on this one. So it does work for this equation because it is greater than -3, because yes, 3 is greater than that. It passes on our equation here that we had to solve for the y. So our slope-intercept form, it passes for that because it is under. Where does it fail? It fails on the y part. Y has to be greater than or equal to 0. So again, we could do this mathematically, but again, just going through that process save us a little time mathematically. All right, last one here. So story problem. So it says a logo contest requires that a logo width be between 3 and 5 inches and height no less than 2 inches, and the sum of the width and the height no more than 9 there. So you can leave them as W's and H's as long as you tell me where the W and the H is on which one you're making which here. Usually with width, that goes along the x-axis because we're going left to right, and a height goes up and down on the y-axis there. So here, I'm actually going to make my width x, so I'll put a little x above that, and then my height is going to be my y. So I'm going to keep them still as x and y's when I come up with my inequalities here. So the first one is a between. So my x has to be between 3 and 5. So again, that looks like this, ladies and gentlemen. So x has to be between 3 and 5. So it is a range. And for that, we like to break it up also because we're going to graph both of those. So I'll break it up here on the second line. So actually this reads as x has to be larger than 3, but x also has to be less than 5. So we can graph those out. So again, we're going to get some vertical lines there. So let's go ahead and graph those out. And they're going to be dashed. So 3, 1, 2, 3. So here it is. I'll kind of move it over a little bit because it's hard to see it when I put it right on the, these are a little darker lines. So there's my x is greater than 3. So again, my little mental note. I'm going to the right of that. And then we have our 5. So I'll go over there and just go off the line just a little bit, just so you can see me dashed. And that is x has to be less than 5, so we're going to go that way. Again, leaving myself little mental notes which way we're going. Alright, so we got that taken care of. Y is no less than 2. So your height can't be any less than 2. So that means we have to have a height that is greater than 2. So y is going to be greater than 2. So we get a nice horizontal line there. So 1, 2, and again it's going to be dashed. So y is greater than 2. And again, we're going to go above for that. So we start to see an area being created in here. So right now, these are all the possible answers. We still have one more here. The sum of the width and the height is no more than our 9 there. So the sum of the width and the height, that's adding those together. And again, no more than. So we're maxed out at 9. We can't go above 9. So again, we've got to solve this for y, so we'll subtract. So y is going to be a minus x plus 9. So we count 9 up. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have a slope of minus 1 and to the right 1, because remember there's an invisible 1 in front of that. So down 1 to the right 1, down 1 to the right 1. And we get those dots right in there. And again, y is below, and again it's going to be a dashed line there. So dashing it in between. And again, that was my y is less than minus x plus 9. Labeling everything here. And we're going to be below. So sometimes when there's like 4, it gets a little tricky here, but again, we're between, we're above, and then we have to be below that line. So the only possible answers are that little 4-sided shape right there. Because I'm above it, below it. I have to be above this line, which I am, and then this line here we have to be below. And then we can answer our questions here. You enter a logo 4 inches wide and 6 inches high. So where is that coordinate? Because again, that's a coordinate. So that's our 4, 6 that we're entering. So 1, 2, 3, 4. All right, so far so good. 1, 2, 3, 4, 5. Uh-oh. There's your 4, 6. Does your logo meet the criteria? And the answer is no. Unfortunately, it does not. And again, you can check this also mathematically over here, ladies and gentlemen. So again, the one where it fails is when you plug it into our y is less than our minus x plus 9. That's where it fails. So I'll just show that here real quick mathematically. So it fails here, so plugging it in, you get 6 has to be less than or equal to a minus 4 plus 9, and 6 has to be less than, and we get an answer of 5 here, which again is false, which again, because we said it had to be below it, so that's where it failed. Thank you, ladies and gentlemen. If you have any questions, always reach out to us by email or hang on after our Zoom meetings and we'll answer those.